All right, so derivatives of trig functions. So here we have 6 additional basic derivatives just of your trig functions. So you need to know that the derivative of sine is cosine, derivative of tangent is secant squared, and secant is secant x tangent x. And that's why having those flashcards is really important. Then you have a series of trig functions that all start with c. And if you take a look at their derivatives, they all have one thing in common. Their derivatives are all negative. So if you think about it like this, any function that you are taking the derivative of that starts with a c, its derivative will be negative. So here, the derivative of cosine is negative sine. Cotangent is negative cosecant squared. Cosecant is negative cosecant cotangent. Okay? And that's basically what I just said right here. Trig functions that begin with a c, their derivatives are negative. So here, let's clarify, the derivatives are negative. Okay, cofunctions, which are complementary trig functions, have similar derivatives. That word is missing. And these fundamental trig identities are extremely important, and they can be used to simplify some of your answers once you take the derivative. And you do need to know these. So these right here come from that hexagon that you guys learned in pre-calc. This double angle, there's quite a few double angle identities. This is one of the most important ones because it comes up a lot. So for example, if you simplify an answer and you get the sine of 2x, and let's say it's a multiple choice question, and you go to look for the sine of 2x, it might not be there because a simplified double angle identity would be in its place. So you need to know this. So let's take a couple basic ones here. If we're taking the derivative of example number 1 here, it says y is equal to sine of x minus the cosine. So y prime is equal to, what's the derivative of sine? It is the cosine. Minus the derivative of cosine. Yeah, so this becomes plus sine of x. It's pretty basic, right? You're just taking the derivative. Now, I don't expect you to know all of these right this second, but I mean, we need to know them, especially by next Tuesday. What do we have to do here? Yeah, we have to use quotient rule. So I need to make the table. Okay, we're allowed to use quotient rule. This is 2, 5. So here we have f is equal to the tangent of x. G is equal to x plus 1. So what's f prime? Yep, secant squared of x. And then g prime is 1. Okay, so the quotient rule is f prime g minus f g prime over g squared. So we have y prime is equal to f prime g, so you have the secant squared of x times x plus 1 minus f g prime, well that's just the tangent of x, over g squared. So what is that, x plus 1 squared? That's your derivative. You're done. Now, one thing I want to caution you on when you are taking your derivatives, especially of these trig functions, some of them can get really long, especially if you're using the secant and the cosecant. So they have 2 trig functions in their derivative. If you just leave your answer like this and then you go into Blackboard and you look up the answer, it's going to look a little different. They might simplify. But if you are confident in what you did, or you can always come and ask me if you want, I would just leave it like that. I mean, really, what are we going to use this for, most likely? To find the slope. Okay, so why would we need to simplify it? Just to make my life a lot harder and increase my chance of making an error. That's the last thing we want to do. Let's take a look at 3. Whenever you can simplify one of your problems before you take the derivative, it might make your life a lot easier. Can I simplify the sine of pi over 4? I heard it. Louder? Square root of 2 over 2. So now what we have is y is equal to the square root of 2 over 2. Describe for me the square root of 2 over 2. Just classify it when you're taking the derivative. What is it? A little bit louder. I heard something. It's a constant. So what's the derivative of a constant? You're done. So if you can simplify, definitely simplify. Let's jump to 5. So not only do I have to use the addition rule here, but I need to use the product rule, right? So let me make a table for this, and I'll do it right here. So we've got f is equal to 2x, g is equal to the cosine of x. What's f prime? What's g prime? Negative sine of x. Okay, so we've got y prime is equal to, take the derivative of x squared, what is it? 2x. Plus, now I need to use the product rule here. So it's going to be f prime times g, so this is 2 cosine of x, plus f g prime. So this actually becomes what, a minus? So this is minus 2x sine of x. Is that right? Okay, so I could factor out a 2, right? But does it really simplify my answer at all? Meaning, is there anything I can cancel? Or so, I mean, if I left it like that, is it really a bad thing? No, not really. Questions on 5? Everybody okay? All right. You have 4 questions there. Pick one, and I'll do one more.
8.
Sure. Everybody always picks 8. Okay. So we have to use a quotient rule. So since I have some space up here, I'm going to make a table. Okay, we've got f is equal to the cosecant of x, and then g is x to the 2/3. Okay, so f prime, what is f prime? Negative cosecant x cotangent x, and then g prime, 2/3. I heard negative 1/3. Is that right?
Yep.
Okay. So that's my setup, and I'm ready to go. So we've got y prime is equal to, so it's f prime times g. So can I put this in front? Because it's kind of like it's a coefficient. Yes? No? Is that all right? Okay, so I've got negative x to the 2/3 power for that negative, and then we've got the cosecant of x cotangent of x, minus, then it's going to be fg prime. So we've got, what, 2/3 x to the negative 1/3 cosecant of x, and then we can't forget about our denominator. So what is that? G squared. So that would be x to the 4/3. Okay, the only issue that I see with this is we have a complex fraction, and if you're not evaluating to find the slope, most likely you will be asked to simplify this. So this is really in the bottom here, true? So how would I simplify this whole thing? By what? To the negative 1/3? Positive, yeah. So we're going to multiply, which I almost have barely no room here. What'd you say? 3x to the 1/3 power over 3x to the 1/3 power. Is that right? Okay, when I distribute, so remember you have 2 terms here. You have this whole thing here and this here. And really what we want to get rid of is what's in the denominator here. And essentially this is in the denominator because it's a negative exponent, right? Okay, so when you distribute 3x to the 1/3 here, you have y prime is equal to, this is negative 1 times 3, which is negative 3. What's x to the 2/3 times x to the 1/3? Yeah, just x, because it's x to the 3/3. So this is x, cosecant, cotangent. And then we have minus, so will this get rid of this green? This 3 in the bottom with this 3 in the top goes, right? This x to the 1/3 in the bottom, because that negative exponent times this x to the 1/3 in the top, cancels. So you're left with 2 cosecant of x. And then in the bottom, you've got 1 times 3, which is 3. And what's x to the 4/3 times x to the 1/3? X to the 5/3. Yep.
Where did you get the 3x 1/3?
This is, so this right here, if I were just to rewrite this part, it's minus 2 over 3x to the 1/3. And then you have the cosecant of x sitting right here. That's just this part. And this is a complex fraction, so remember you have to multiply by the least common denominator, which is this.
Okay.
Any other questions? Okay, the rest of these are on Blackboard. I highly recommend you practice and go take a look. Let's take a look at this last example on the bottom of page 16. So here we want the second derivative. So the first thing we need to do is take the first derivative. So dy dx is equal to, what's the derivative of the cosecant? Yep, negative cosecant cotangent. Okay, so when we want the second derivative, I have to use the product rule. So I'm going to make my table right here. We've got f is equal to negative cosecant of x, and g is equal to the cotangent of x. So we've got f prime. The derivative of the cosecant is negative cosecant cotangent. So what's the derivative of the negative cosecant? Positive, right? Same thing, but just positive. So this is cosecant x cotangent x. Okay, and then what's the derivative of the cotangent? Negative cosecant squared? Is that right?
Yeah.
Negative cosecant squared of x. Okay, so here we have the second derivative. Notation like this. All right, so it's f prime times g. So what do I get when I take cosecant cotangent times the cotangent? You're multiplying. Yeah, you will go to cotangent squared. So you have cosecant of x, cotangent squared of x. Okay? And then, so that was f prime g, so then it's f g prime. So I have a negative times a negative, so this will still say as positive. And what is that, cosecant cubed of x? Because you have a cosecant squared times. Okay, questions? Are you sure?
Sorry.
Yep, that's okay. Do the product rule? Okay, so it's f prime times g. So f prime, cosecant, cotangent, times a cotangent. So that's where I get the cotangent squared. Then before I put the plus here, I want to make sure that I didn't have a positive times a negative. So then it's fg prime. So it's a negative times a negative, which makes a positive. Yes, sir?
So we should get in the habit of simplifying the derivatives of trig functions more than we did like in the last year because we were just finding slope. So
it depends on what the question is asking, really, to be honest. I practiced right here simplifying this because some people still continue to struggle simplifying complex fractions. And this is just something very minor, but it will come up where you might be asked to take the derivative, and then it'll say provide your solution in simplest form, which means get rid of your complex fractions or simplify negative exponents. Radicals in the bottom still are fair game. You guys are allowed to leave radicals in the denominator, unless, of course, it were to say something